Do you know that over 60% of post-UTME candidates fail chemistry questions? Not because the questions are too hard, but because they don't understand the tricks examiners use. In today's section, we're going to expose these tricks with detailed explanation so you never be confused again. Hello there and welcome back to HelpGrow Academy, your #1 exam prep hub. If you're preparing for Post-UTME Chemistry, you're in the right place. In this video, we are going to tackle some very important theory-based chemistry questions. No long calculation, just pure understanding of concepts. Stay with me to the end because I have prepared a bonus question that's really tricky. Most students fall into the trap, but if you get it right, you'll be among the top 10% ready to crush Post-UTME Chemistry. Before we dive in, don't forget to hit the like button, share this video with friends who are also preparing, and subscribe so you don't miss the next practice section. The first question we have for today says, which of the following is a chemical change? Option A, melting of ice. Option B, tearing of paper. Option C, rusting of iron. And option D, breaking of glass. The correct option here is option C, rusting of iron. In chemistry, we classify change into physical and chemical changes. A physical change, don't forget, affects only the state, shape, size, or form of a substance, but it does not alter its chemical composition. It is actually reversible. Examples include melting of ice, boiling of water, tearing of paper, and breaking of glass. In each case, no new substance is formed. For instance, melting of ice is still water. A chemical change, on the other hand, refers to the formation of new substances with different chemical properties. Such changes are generally irreversible and involve rearrangement of atoms. Rusting of iron is a chemical change because iron reacts with oxygen and moisture in the environment to form hydrated iron 3 oxide, which is rust. These chemical properties of rust are different from metallic iron. Since a new substance has formed, rusting is chemical and not physical. So the correct option there is option C, rusting of iron. Question 2 says, which of the following best describes isotopes? Option A, atoms of the same number of protons but different number of neutrons. B, atoms with the same mass number but different atomic numbers. C, atom with different number of protons and electrons. D, atoms with different number of protons and same number of neutrons. The correct option here that best describes an isotope is option A, atoms with the same number of protons but different number of neutrons. Now let's explain what is an isotope. Isotopes are different forms of the same element that have the same atomic number, that is number of protons, and different mass number because they differ in the number of neutrons. For example, we have carbon. Carbon has 3 naturally occurring isotopes. We have the carbon-12, which has 6 protons and 6 neutrons. We have carbon-13, which has 6 protons and 7 neutrons. We also have carbon-14, which has 6 protons and 8 neutrons. Now all are still carbon because they have 6 protons, which is the atomic number remains 6, is unchanged. Isotopes often have similar chemical properties because their behavior depends on the proton and electrons, which remain the same. However, they may have different physical properties like mass and stability. It might differ. For instance, carbon-14 is radioactive and is used in carbon dating. So the correct option there is option A. Isotopes are atoms with the same number of protons but different number of neutrons. Question 3 says, the first person to introduce the atomic theory in modern chemistry was. The first person to introduce atomic theory in modern chemistry was A. J.J. Thomson, B. John Dalton, C. Ernest Rutherford, and D. Niels Bohr. The correct option there is option B, John Dalton. In 1803, John Dalton proposed the first modern atomic theory. His key ideas include 1. All matter is made up of small indivisible particles called atoms. The second idea was that atoms of the same elements are identical in mass and properties. The third one is atoms of different elements have different masses. And the fourth one, atoms combine in simple whole number ratios to form compound. Although his theory was revolutionary, part of it were later modified, like this one that they said atoms are not indivisible. They contain both protons, neutrons, and electrons. And also, atoms of the same elements may differ in mass. That's isotope, the previous question we just solved. So later, scientists also improved this model. Scientists like J.J. Thomson, Rutherford, and Niels Bohr. J.J. Thomson discovered the electron, Rutherford discovered the nucleus, and Niels Bohr developed the planetary model. John Dalton is credited with laying the foundation for atomic theory in chemistry. So the correct option there is option B, John Dalton. Question 4. Which of the following is not a noble gas? Which of the following is not a noble gas? Option A, helium. Option B, neon. Option C, argon. And D, nitrogen. The correct answer here is nitrogen. Nitrogen is not a noble gas. Now, what are noble gases? Noble gases are elements in group 18 of the periodic table. They include helium, neon, argon, krypton, xenon, and radon. These are the elements in group 18 of the periodic table. Their most important property is that they have completely filled outer shell. Their outer shells are completely filled, making them very stable and unreactive. For example, helium has 2 electrons filling its first shell, while neon has 8 electrons filling its outer shell. Nitrogen, however, belongs to group 15, not group 18. Its electronic configuration is 1s2, 2s2, and 2p3, meaning it has 5 valence electrons and it is not inert. Nitrogen readily reacts to form compounds such as ammonia and nitric acid. Therefore, the correct answer is nitrogen, since it is not a noble gas. Nitrogen belongs to group 15 and not group 18. Don't forget, noble gases are elements that belongs to group 18. Nitrogen does not belong there, so it is not a noble gas. Question 5 says, which of the following processes is used to separate crude oil into its components? Which of the following processes is used to separate crude oil into its components? Option A, filtration. B, fractional distillation. C, chromatography. And D, crystallization. The correct option there is option B, fractional distillation. Don't forget, crude oil is a mixture of different hydrocarbons such as petrol, kerosene, diesel, lubricating oil, and bitumen. These hydrocarbons differ in their boiling point, so they can be separated by fractional distillation. In this process, crude oil is heated in a large distillation tower. Components with lower boiling points rises to the top and condense first. Components with higher boiling points condense lower in the column. Other methods listed above are not suitable, like filtration. Filtration separates insoluble solid from liquids. Chromatography separates mixtures of colored pigments or similar compounds, and crystallization purifies solids from solution. Therefore, fractional distillation is the correct method used in petroleum refineries for separating crude oil into its components. Question 6 says, which of the following is an alkaline? Option A, sodium hydroxide. Option B, aluminum chloride. C, hydrochloric acid. And D, carbon dioxide. The correct option here is option A, sodium hydroxide. What are alkaline in the first place? Alkalines are a special group of bases that are soluble in water and produce hydroxide ion when dissolved. Now, the first option there, sodium hydroxide, is a strong base which dissolves in water completely to produce sodium ion and hydroxide ion. It is a classic alkaline. The second option, which is ammonium chloride, is a salt formed from a weak base of ammonium and a strong acid of hydrochloride. It is not an alkaline. The third option there, which is hydrochloric acid, is an acid and it is not an alkaline. Option D, carbon dioxide. Carbon dioxide is an acidic oxide that reacts with water to form carbonic acid. Hence, from the option there, only sodium hydroxide qualifies as an alkaline. So the correct option there is option A, sodium hydroxide. Question 7 reads, which of the statements about catalyst is correct? Which of the statements about catalyst is correct? Option A, they are consumed during the reaction. B. They lower the activation energy of a reaction. C. They increase the enthalpy change of a reaction. And D. They are always solids. The correct option here is option B. Catalysts lower the activation energy of a reaction. Now let's give a very detailed explanation. Catalysts are substances that speed up the rate of a chemical reaction without being consumed in the process. They function by lowering the activation energy, which is the minimum energy required for a reactant to collide and react. There are very important points to note about catalysts. One of them is that catalysts are not consumed, so it makes option A to be wrong. The next thing to note is that catalysts do not change the enthalpy of a reaction, they only affect the pathway, so option C is wrong. The third thing to note is that catalysts can exist in different forms. It can exist as a solid, liquid, or even biological, that's enzymes. So they don't always exist as a solid, so option D is wrong. Therefore, the correct statement about catalysts is that catalysts lower the activation energy. That is option what? B. So the correct option there is option B. They lower the activation energy of a reaction. Question A says, which of the following is a strong electrolyte? Which of the following is a strong electrolyte? Option A, sugar solution. B, distilled water. C, sodium chloride solution. And D, ethanol solution. The correct option is option C, sodium chloride solution. So let's explain. What is an electrolyte, if I may ask? An electrolyte is a substance that conducts electricity in a solution by producing ions. Simple, that's what an electrolyte means. Strong electrolyte deassociates completely in water to produce a large number of ions. Now let's analyze the options together. Sodium chloride dissolves in water to form sodium ion and chlorine ion, making it a strong electrolyte. Sugar solution, on the other hand, does not ionize in water, so it is a non-electrolyte. Distilled water, on the other hand, is a very poor conductor of electricity, since it has almost no ion. Ethanol is a covalent compound and it does not ionize in water, hence it is not an electrolyte. Therefore, sodium chloride solution is the correct answer. It is a strong electrolyte. Question 9 says, which of the following best explains why metals are good conductors of electricity? Which of the following best explains why metals are good conductors of electricity? Option A, they have low melting points. B, they contain delocalized electrons. C, they are highly reactive. And D, they have large atomic sizes. The correct option there is option B, they contain delocalized electrons. The very unique property of metals is metallic bonding, where positive metal ions are surrounded by a sea of delocalized electrons. These electrons are free to move throughout the metallic structure, which explains why metal can conduct electricity and also conduct heat. The other options are incorrect. Melting point does not determine conductivity. Reactivity is a chemical property not directly related to electrical conduction. And atomic size does not explain conductivity. Hence, metals conduct electricity because of delocalized electrons. Question 10. Which of the following pollutants causes the depletion of the ozone layer? Which of the following pollutants causes the depletion of the ozone layer? Option A, carbon monoxide. Option B, chlorofluorocarbon, that's CFCs. Option C, carbon dioxide. And option D, nitrogen gas. The correct option there is option B, chlorofluorocarbons, CFCs. The ozone layer is found in the stratosphere and it protects life by absorbing harmful electroviolet rays, that's harmful UV rays. CFCs, that is chlorofluorocarbons, used in old refrigerators and air conditioners, break down under UV radiation to release chlorine radicals. These chlorine radicals react with the ozone, converting it into oxygen, thereby reducing the thickness of the ozone layer, making it more thinner. Other pollutants like carbon monoxide is a poisonous gas. It binds the hemoglobin, reducing oxygen transport in the blood. We also have carbon dioxide. It's a major greenhouse gas responsible for global warming. but not ozone depletion. Nitrogen gas is inert under normal condition and not a pollutant. Therefore, CFCs are the main cause of ozone layer depletions. Now we have the bonus question. Try this question and leave your answer in the comment section. The question says, which of the following substances is classified as an amphoteric oxide? We have option A, B, C, and D. Don't forget to leave your answer in the comment section. And that's a wrap for today's class. We have gone through 10 solid chemistry questions plus a tricky bonus question to sharpen your brain for post-UTME chemistry exam. Now here's your task. Drop your answer to the bonus question in the comment section before I reveal it in the next video. Let's see how many of you are truly ready. Remember, practice makes perfect, but detailed understanding makes you unbeatable. So keep practicing, keep pushing, and success will be yours. Don't forget to like this video, share it with your friends, and subscribe so you don't miss out on the next section. Until then, stay sharp and keep winning. See you in the next video.